Всім дуже дякую. In order to be not so rushful and quick, let's talk in English, because if I start talking Ukrainian, we'll just skip most of interesting topics. So just please also, if you see something, if you are interested in something, just stop me, just ask me to zoom in something. If you don't understand, please feel free to to ask for additional explanation. So today I'm going to talk about OTP platform. As the previous presenter said, what is an OTP? No one doesn't know it. It's very complicated. So let's start from the very beginning. Who am I? I am Oleksiy Kurnenkov, working in ONAP, and recently I've created GitHub account using my real name. Okay, so I'm going to push all the code that you see here, plus maybe something additional. And let's start. So here is our roadmap. It's starting from gears. First of all, we're going to initialize our conversation about an OTP and Erlang and Elixir, etc. Then we'll talk a little bit about behaviors, and we'll open the topic of generic constructions, generic servers, etc., etc. Then we're going to cover supervision, which is very powerful and a little bit mentioned by our previous presenter. Then we'll see how to deal with applications and what are they, in fact, and what are releases, and how to handle and upgrade. I mean, live upgrade. I hope we'll cope within 1 hour. So, if no, we'll just take beer, and who is interested will just proceed if you want. Okay, so let's start from the very beginning. This is first gear. It's in red. It's initialization of OTP. So, what is the OTP? No one knows, and it's really set of just toolkit. It's a collection of best practices, of design patterns, of utilities, of applications, and yeah, I totally agree with that. OTP is not the best name for it, because it does not only something with telecom, but it's in general with Erlang applications. So it's like if you take Java and or Ruby and just package like standard factory into standard library or standard observer. By the way, Ruby has GenericServer. Okay, so let's continue. Erlang and Elixir fundamentals. So both languages, the most important thing and notion is process. So we'll talk about processes, about messaging, about links, and Björn and Erlang abstract machine, or Bogdan's. So process is a single concurrency. It's single concurrency unit. It's not the operating. It is not mapped as a 1-to-1 to the operating system process or thread. It's more like object in object-oriented language, but it's true parallel. So in fact, every process is an actor, and there is a framework. There is a notion of actor system. I'm not going to talk today about it, but how can we spawn a process? By the way, how many of you are already not just aware but familiar with Elixir? So just typed some scripts, some programs. Okay, so 30%. Fine. And what about Erlang? Oh, 2 of you. Great. Okay, so most of all, I have examples in Erlang and in Elixir, and if something happens, I just skip Elixir or Erlang. So in both languages, we just use construction or standard function spawn. it accepts module, function, and a list of arguments. So you give process a module, you say which function to use in order to initialize it, and a list of arguments. And also our program can accept just unnamed function to spawn process. So let's take a look at example. This is very simple. So it's okay. Let's dig a little bit into syntax. It's an Erlang. Every function finishes with period. So just like normal language, normal sentences. If you plan to go to the next line, you just use comma, semicolon. So here, what we are doing, we say that our module is called process, and in Erlang we need these boilerplates like exporting functions. So we can't say which functions are private and public, like in Ruby. In other languages, we don't have accessibility attributes. But we have exports, so if any function is not exported, then it's considered as private. And functions are just like this. So parentheses are mandatory, and even if you don't use any arguments. So what we do is we spawn a new process via calling a start function, and this process executes just during initialization, executes hello function, and its I/O format, it's like puts in Ruby, and its interpolation, it's something very interesting. And okay, so let's move on. And this is the same example in Elixir. We have our process definition, I mean module definition, which is called process, and we have the same start and hello functions, but to the contrary from Erlang, we don't use exports. We just use def or defp in Elixir, and interpolation works just without any problem in Elixir. I mean, it's more common for us as a Ruby developer. So let's open our console. Oh, sorry, my virtual machine. Just let's go to the code to init. Let me, yeah. Init. So we have, okay, let's go to Erlang. We have our process Erlang. Is it good? Okay, let me do this. As you can see, we have some Beam files. They are already compiled versions of, I mean, just a bytecode which will be executed directly via Erlang machine. So let's compile our process. Oh, sorry. Let's compile it. Erlang. This is compilation. It's without any warnings. This is not mandatory step, but if we open our console, we can do the same. We just compile the process module, which sits in this directory, and it's here. So we can see our process here. So process, and we have our let me recall process Erl. I'm using item. If something is wrong, please let me know. Okay, so we just have our start function, and let's go directly into console and just so it starts. So what we can see here is a process identifier within a virtual machine, and it just puts or outputs some hello from his PID, and that's it. This process just evaluates function and doesn't loop, doesn't hang forever. It just exits and without any problems. So let's go to our slide. So this is it, basically. And the second fundamental part is message. So in Erlang, what is the difference between Java, C, Ruby, and what annoys me very, very seriously in Ruby, unfortunately, is the idea of shared state. So of course we can communicate, we can establish communication between different applications, between different processes using messaging, third party. But in Erlang it's just shipped. So shared state is counter-natural. So in Erlang we use messaging like people, because actors are just like people, and we don't share brain. So it's nonsense if I say let's here you are. It's your mutex. Let me use your brain for a while, and then give me mutex back. So it's nonsense. So actors use messages. So this is our first process, this is our second process, and they just use bang and send messages to each other. And it's very simple in construction in Erlang. I'll show it a little bit further. So every process has its mailbox, like people have. So it's mail. New message comes into mail, and process has selective message consumption, so it can discard something and can agree or process. So this is a selective receive. This is a construction of receive. Then you pattern match with your incoming message. You do something with this. Or if it's rubbish, not rubbish. If it's rubbish, you just ignore it. So it's in Erlang. Here, it's a little longer, but let's be prepared, because we have more interesting examples. So it's just the beginning. So it's the same construction. We have our module definition, we have our exports, and what is the most important is that we have our loop, which is recursive. Oh, by the way, is there a pointer here? Is there a laser pointer?
Yes.
Could you please? Oh, yeah, thank you. Okay, so yeah, so this is. So we execute, our process starts, shaky hands, our process starts, then it spawns unnamed anonymous function, and which starts executing loop. So what happens? This is a just static file, it's just an instruction what to do. But the real magic happens, one moment, yeah, here, when we start executing loop. So we spawn standalone process as like an object, which is a concurrent unit. It can accept connections. It can process, receive messages, process data from database, parse files, etc., etc. So it does it in parallel to your shell, in parallel to the world. So, and what it does here is it just receives message, outputs its content, which is message, and from it's just a convenient way of passing messages between process. So we have the same construction for output. I'm using it everywhere here because it's the most simple thing to just put or output. And yes, so we receive our message. We send reply to the process which sent us this message. So this is it. And in Elixir, it's mostly almost the same, just more do and. So we have the same receive statement. We have pattern matching. We assign some PID. I've just used additional variable because kernel inspect. I don't know. By the way, do you know how to pretty print PIDs in Elixir without falling back to kernel inspect.
Just inspect.
Okay, just inspect.
You
Okay.
can inline inspect calls inside.
Okay.
And you don't even need to specify the kernel.
Okay, thank you. Yeah, and Elixir uses send, and again it loops, so it's our loop. Okay, and links. So link is the mechanism or primitive which is supplied by a virtual machine in order to different processes to keep an eye on each other. So one process is very happy, and he meets his friend, and spouse, and they just have a link between them. What it means? It means that if one process goes down, I mean exits with any reason except normal, then our one of processes receive just exit like the mail of reason of death. So yeah, he's upset because he receives exit signal. And yes, one more slide. So here I'm highlighting this construction. This is a process flag. What it means is it means that if the process doesn't trap exits, it just exits as well as his counterpart. So if your process, like if your object gets an exception, which is like exit message from other processes, if it doesn't trap it, it understands that he should just finish his activity. So here we use very common, which is very, I mean, it's vital construction, start link. It's used everywhere in OTP. It's a convenient method or convenient function which uses spawn link. What is the spawn link is the same as spawn plus link, but the operation is atomic. So you don't spawn process and then link to it, because in meantime it can just crash and you don't ever receive error message from this process. So if something happens wrong during the initial function execution. So we spawn a link. As well, we use the same construction like module, first function to, initial function and list of arguments. I just use nothing here. And yeah, our process just executes something and exits. In Elixir, it looks like almost the same. So we are just starting the link. We use a little bit different construction as our previous guy said, that Elixir categorized functions, so they use module process instead of just calling Elixir or registry or Erlang blah blah blah, registry blah blah blah. They use one namespace for process management, which is very good. So they use the same idea. They trap exit signals, and after this, we spawn this in the same way. We start receiving our message, and we just exit after we receive first message. So if you can see, we don't iterate. I mean, there is no recursion here, and hello is just simple enough. And here our process exits. Enough of this. Can't find Erlang's E. Yes, this is this is what I was saying. Okay, let's sorry, it's yeah, it's Windows feature. Once. No. Okay, let's exit and see. So we need our link process. Let's execute our Erlang console once again. We just compile link process and period, and we execute start link, and this is it. so our process, I mean shell. So shell is yet another process. It has its PID of this. This is the PID of shell, and this one was the PID of the process which was spawned and exited very early. Okay, so this is it. Sick and tired. Yes. Yeah, we receive. Okay. So it's Windows. Yeah. Okay. Okay. So we move on to our next conversation, our next topic. What is a beam? Yeah, you already know it's not a beam of light, but it's very, very romantic. It's Bjorn's Erlang abstract machine. Is a virtual machine for Erlang beam bytecode execution. And I prefer Bogdan's because it's more patriotic form of beam. And let's compare it with our beloved Ruby virtual machine. So our Ruby utilizes one CPU core, unfortunately, and our rough application looks like this. It's it's a bike with one cylinder, and after some refactoring, we have this beautiful project, but still with only one cylinder. So only one, if not using Rubinius or JRuby. And Beam, it scales to all available CPU cores. It's like this. Yeah, so it's real. Or after refactoring, it's more like this, and your application sits on top of it and can do lots of funny stuff. Yeah, so okay. And also Beam distributes over all available nodes within a cluster. And these guys, they are sad because they have to maintain all these clusters. So what is debugging? In a nutshell, it looks like this. So you have a tracer, you have debugger, you have some utilities, and so this is it. So multiprocessing. If you have a JVM, you have a heap of objects with shared memory. It's benefit of sharing memory. So that's it. But if we have our Beam, it has nicely separated cores. It has its scheduler. It has its resource scheduler, and already built-in constructs to inter-process communication. So if you say your Beam or shell, I mean your Beam instance, to use like 8 cores, it will use 8 cores. If you limit it by using 1 core, it will use 1 core, and it distributes processes, as I said, concurrent units of execution optimally over all your cores. So if those processes are lightweight, they just can be executed on different cores. So on one core. What is the most significant here is that this is a true parallelism for free for 50 megabytes of memory. So it's nothing comparing to JVM. It's nothing comparing. By the way, Go has the same principle. I mean, resource allocation. And in Go, these processors are called Go routines, but it's not about Go. And what else? It's a very nice feature. It's a per process garbage collection. So if one process gets a lot of unnecessary data, it has its dedicated garbage collector. It just maintains it, and everything gets cleared. So it's basically done. This is the fundamental. These are fundamental knowledges about OTP and Erlang. Okay, so constituent parts of OTP framework. These are behaviors and actually what is the behavior, the idea of behavior, then generic constructs or constructions, then supervision and supervision trees, and application releases, and it's great because we are not going to cover it today because it's the topic for standalone session. I hope someone from you will pick this topic also. Okay, so about behavior. Let's talk about it. So blah blah blah. Lots of text. It's from official documentation. But what is the most important here is that it's separation of generic part from specific part. It's just a behavior modules and callback modules. And there are lots of, as in lots of books, just use this feature while writing, and while reading books, you just read about lots of code, lots of design principles, and at the end of the chapter, author just skips all the code and says just use GenericServer or generic event manager, and that's it. So in order to understand the whole idea behind OTP, you just have to type or to think about it, to meditate. I don't know how to call it. Okay, so what is a behavior? So our process, we have two modules or two containers of your logic, which is the behavior module and the callback module. So using callback module, you just actually spawn or conveniently spawn a new process. I'm very happy, and it uses behavior module to communicate with each other. It looks like absolute nonsense at this moment, but we shall see what is so powerful here. So let's take a look at our own behavior. It's just generic module plus some plugin. And yeah, it's a bit more coding here. Let me see if I have Elixir here. Oh, yeah, we have Elixir. Would you like to skip Erlang and just go with Elixir, or we'll go hard way, the hard way? Okay, so generally in Erlang it's less code as for me, but you still have to export explicitly some functions. So this is our our conveniently called client API. Sorry. This is a behavior definition. This is what is intended to be the first. So we define our module, call it generic mod, generic, I don't know, mod, and export some functions which are start, connect, and info. This is our API, and this is basically what defines and determines behavior. What helps compiler to determine behavior from another part of the program. So if your module states that there are callbacks which are necessary to be implemented in your client module, then it's a behavior. And further, it can be used as a standalone behavior. So we have our pretty simple functions, but what is the most important here is this apply function, which is basically meta programming, because we can dynamically call whatever we need. So here the main idea for generic part of behavior is to wrap your code, your specific part into some generic part, and provide some housekeeping behind the scenes. This is how basically every behavior behaves. So we have this is apply. So we just accept the module. We just call some function on it. We understand. So this is our contract. This is our API, which we require from every callback module. So we call doStart with something, and on connect we call doConnect. It doesn't mean anything, but here we have callback and optional callbacks. Optional callbacks provide you with the default definition just in generic module, but simple callbacks just must be provided or implemented in your client code. So this is our plugin which implements generic module which if you come here from Java world, you can understand that it's like an interface. So this module or this class implements interface provided by generic module. So these are callbacks which are necessary for our program to even start. I mean, for compiler to even compile this, because if there is if something is missing, then compiler says that your model doesn't comply with the contract, with the requirements of behavior. And this is so this is the common pattern in all generic in all generic constructions, which we will cover later. So this is public API, which you call from everywhere, and via generic module, using just code, you execute function and apply this module. It may sound like mayhem, but it's very powerful. So let's have a look. In Elixir implementation, I just can't, unfortunately, can't find optional callbacks in Elixir definition, behavior definition, but I think it's just the matter of lack of experience. So we have the same situation here. We can also state our return values, our accepting which data types we accept, and basically we should do this here in a callback definition. And these are our generic part. So we call module do start. We don't use apply as in Erlang. We just call method or call function directly on module and return something. And here is our client code, which basically is a sibling of I don't know. So this is the same. We have some API, we have some callbacks, and let's take a look into our console, which of course has been already locked out. This time let's do some Elixir behavior. Elixir. Okay, so what we have here is generic module, generic plugin. Let's start Elixir console and compile generic gen mod x blah 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 gen plugin. So we have our plugin, and we don't need to call a generic module ever, because our plugin defines a public API for this. So it just calls start, and implicitly, if you remember it, let me open this, do start. Okay, so our plugin sends itself to generic module to apply some callbacks. So it's very simple, and it doesn't make sense at this point, but if we take a look into GenericServer implementation, let's do this. Sorry, this is very interesting. Okay, so here is our GenericServer Erlang. Yes, and it's not as simple as we write our own definition. It has 800 lines of codes, including documentation. So we can see our exports, we can see our import yet another construction. Here are our callbacks, and with some API specification. Yes, this is it. So that's it. So in fact, generic constructions in Erlang are not so simple, as we can see, and Elixir provides additional wrapping on top of this generic const. Okay, let's move on. So which are generic behaviors? These are generic server, generic event, state machine, which is rather fresh, and it is intended to substitute generic FSM. We are not going to cover generic FSM. We'll cover application, as I already said, and supervisor. So let's move on. It's our third stop, generic constructions. So we'll start from generic server. And what is the pattern of using every server, including generic? We need to have an ability logically to start it, to handle synchronous calls and asynchronous calls, which are very important in concurrent applications, because sometimes you don't want one code to wait for another code to handle some powerlifting behind the scenes. It just needs to proceed its execution. Then we need to have the ability to upgrade our system, and of course stop server. So common server, its usage can be depicted as this. So we have our client, we have some API module, some module which provides API, and our client calls module which spawns server if necessary, and this we have another client, and etc. So in fact every client end up communicating with our server, and server replies back to our client. And so this is the common server. We saw this almost this. So the pattern is, we have our API, we have our initialization, and here we also use registration of processes. This is its name. By the way, in Elixir you can see like symbol-like constructs. They are atoms. In Erlang they are just words without any punctuation. So this is we register our module, our process as a singleton. It's been registered locally. Then we spawn our module and apply some function with some arguments. And we have our API to communicate with this server. So we have directly we can communicate with our singleton. It's just a name. It doesn't mean necessarily mean a singleton pattern, but in fact we have one instance of server, and we want most of our clients to communicate only with this instance of server, which is quite logical behavior. But and we can directly use process name instead of PID, because sometimes servers can restart and register itself again, and our client can have the ability to just send messages to this server. So behind the scenes, our server starts its loop, and it just receives messages, provides some state. And this is also a very important thing, because you don't quite often you need servers with state. Stateful is great, but what if you need some history, some messages, something, some lists of nodes of clients to maintain? So you just pass it as initial argument to init loop, then you perform some computation, and call the loop again, but with not updated, but new state. Because in Erlang we have immutable variables, so they are not variables, but they are immutable. What I do dislike about Elixir is that it disguises this behavior. So it wraps immutability. It provides you mutable interface, so you can just assign new values to your old variable. So in Erlang we can't do this, so we just use new variable, and we recurse once again. So we have selective message here. If we get if our process receives get state, it returns something. But if it receives some rubbish, something which you don't care, it just assigns a new state and it tracks like history. Okay, so let's see what happens. It's everything is okay when you have one client and they just pass messages around. You have another client, everything looks very structured. You have more clients, you have more messages, and you have even more clients. And if you forget to handle exits, your server crashes, and you understand that not only server crashes, but your whole application crashes, and you start asking yourself why, what happens, and how to avoid it. And at this point, we understand why this man is so sad, and and why he points his rifle at his face. So sometimes he just says us, just learn OTP if you want to use Erlang. So just use generic constructs, namely GenericServer if you need something. Because as I showed, GenericServer provides very standard API with callbacks. All clients use these callbacks. If server receives some messages directly, they are treated as something unusual and abnormal within your application. So this is it. This pattern is reoccurring again and again, and we have the same situation. Our clients use some code and via this code they receive some abilities or facilities to communicate with server. They might not know about the existence of server, its speed, its identification, whether it's located on this particular server within this particular node, or it sits somewhere around. All clients have is guaranteed contract and behavior which do all heavy lifting for you using 800 lines of code. Okay, so which callbacks we have to implement in order to get GenericServer? These are sort of management. I call them management callbacks. These are initialized, namely init, because if you call it something, if you give it another language, you'll get a compilation error. Then terminate if you want to stop your server, and code change to hot code swap. And then you have a series of handle calls, handle casts. So handle call, there are also handle multi-call, handle multicast. No, not multicast. So this is a synchronous call to our server and to GenericServer instance, and this is asynchronous call to GenericServer instance. And handle info is just to handle some other messages. So we have some sort of mapping between GenericServer and callbacks module. So when GenericServer starts, it executes init function. When GenericServer receives call, it executes handle call, etc., etc. You can read everything within Erlang and Elixir documentation. I'll talk a little bit about Elixir documentation later, but now let's take a look at our canonical GenericServer implementation. So we have our module, which is named like GenericServer 1, very creatively. Our behavior, so this is the instruction for compiler to use to to check whether your callback module complies with all generic behavior required contract. Then we export some management API. Then we export some callbacks. This just has to be done in Erlang. And we have our implementation of API. So our start link of GenericServer 1 behind the scene communicates via GenericServer behavior with our local, some process. And it can start it, stop, etc., etc. You can do whatever you want. So it is absolutely necessary to provide initial state. It can be empty list, anything, but it must be set here. As I mentioned earlier, this state is being used to recursively call itself again. So in a loop cycle. So we use this state. And if we handle call, we need to set like symbol or atom reply, then really some reply which eventually passes to your caller, to client who calls this API. So this is some reply, and once again state to again loop. So I will not mention it further. I think you understand everything. Let's assume. Okay, so when we handle cast, we set no reply sort of flag, but we still set state. We can handle different messages, and also we don't reply to them. We have some termination, we have some reason which we can use in our computation, in our logging, etc., etc. And we have our code change from old version to current version with state and some extra arguments. So this is the place when you where you can redefine, when you can convert the state of your server during upgrade. So if you used like tuples and you want to convert them to lists, this is, and without stopping your system, this is the callback for you. Okay, so it's expanded version, more advanced. I think that it's better to open it in Atom, and moreover, we can even not stand on it. Messages server Erlang. Okay. So we have our functions, our API, and some housekeeping, some boilerplate. So this is the server which sort of records history of our messages. If we send some message to someone, we get it logged, and we don't reply because it's a cast, but we set new state, like we add additional tuple using this head and tail construction in our lists, and etc., etc., etc. Let's just execute it. Okay, behavior, GenericServer. What do we have? Let's use Erlang once again. Messages server. Okay. Messages server. MSG server. Bam. And we have message server send something. What should we use here? We are going to okay, here is our public API message to okay. So I love Ruby. Yes, I do. Okay, message server, and it just receives it and it doesn't reply to you. But if we also we can I didn't start it. Okay, start link. Bam. Okay, now it's here. Let's take a look why I was asking why I was asking about I utility. Is that we have our messages server registered as a process ID number, blah blah blah, with reductions, with some internal state. So now we can send something, and we can get history from it. And we can see that someone called send command at this time. So it's very simple. And what we need to know here is, one moment, it's just an implementation, blah blah blah. Sorry, GenericServer. Okay, so this is it. I don't implement it in Erlang. Yeah, only in Elixir, only in Erlang. So GenericServer, we start link. This is our API. We can start, so we are as a client, start server via messaging server module. We can call send something to something and track history. And behind the scenes, messaging server uses GenericServer behavior to execute start, call, blah blah blah, and GenericServer module communicates, like spawns messages to our real server. This is it with GenericServer, and let's move on to event. Let me see. Oh, okay, sorry. Event. So we also have the common pattern of using event manager. We start event dispatcher or event manager. We register different handlers. We detect events, basically, notify event handlers, which is really common practice. And I don't know, in Ruby we use observer, but we can't do this really in parallel manner because our Ruby is not parallel. And if we use JVM with threaded, etc., so we have the necessity to communicate state and like manage handlers and stop event dispatcher. So live upgrade also. So the core concept is an event manager, dispatcher. Yeah, this is a dispatcher. So and this is also a dispatcher in our code. And common event management, like animation is this. We have a generic event manager API. This is also already written for you. We have our event manager. We started, so we start event manager via its API. It's very, I don't know how it's called. Okay, never mind. We have a set of event handlers that we can notify. So basically event manager sends a replication of messages to all event handlers. And if you write your system in a canonical way, every event handler will spawn event processor, but not process it on here because all those calls are synchronous. I don't know why. It's just so if we have second client, he calls API also, yeah, to communicate something. So different callbacks. Everything here is built on callbacks, and it's nothing we can do with this. So we also have this common init, terminate, code change, and one new is event, handle call and handle info. You already know it, and we have some sort of mapping. What is new here is add handler, which initiates new module, notify which basically notify, yeah, which basically calls handle event on all event handlers, and the delete handler, blah blah blah, swap handler, and the different, yeah, up downgrade, they are could change. Okay, so client handler, Erlang. It's someone. Is it normal for you guys? Far here, yeah, yeah, of course, you like it, yeah. Okay. What? Gen event. No, handler. What? Let me open it in client handler. Yeah, sorry. Client handler. Yes. Okay, so what is necessary here to understand is handle event. Is it better? Yeah. So we handle different events. They are custom, they are not predefined, and we handle some abnormal event. Also we have these handle call, etc. construction, which you already know and aware of. And we implement generic event behavior. So let's take a look into our console. Generic event. What? Oh, Elixir version. Client side handler. Okay, let's open Elixir. Nothing changes. Okay, compile. Client state handler Elixir. Redefining module client event. Okay, so one moment, please. Let me check. What should we do? So we have to start our system, I mean generic event. Let's start it before. So first of all, we need to start arbitrary generic event instance and register it as locally as a state manager. What? Ah, okay, it's Erlang version. Yeah, sorry. Yeah, gen events. Thank you. Start link. It's name statement. Okay. So we have to register our handler. Add the handler. Yeah, add handler, which is a client state handler. Client state handler. No. Okay. What? Let me check this in Erlang. Yeah. Client state handler. Sorry. Okay. Client handler, sorry, yeah. Okay. Client handler. And for those guys who just don't want to learn Erlang, yeah, you should. Okay. So okay, event. Sorry? Event. So generic. Okay. Yeah, let's just copy and paste it. Okay, we've registered. We have spawned it, and let's see what is here in registry. Yeah, so we have our state manager. It's registered as a PID number blah blah blah, and its code is init blah blah blah. Okay, so we can add handler. Yeah, gen event. No, we don't want. Yeah, we want to add handler state what I'm trying to show is to demonstrate how event manager works. So what do we have in online offline? So we receive only 2 events. This is our API, and add notify. Let's. What is this? Notify. Okay, so we simulate this. This is like the name of our client, and what just happens here? So generic event sends a handle event message to our handler module. Everything is simple and yeah. This is exactly how I feel when learning Erlang. Okay, so let's proceed. And this one is the last generic construction which is shipped with Erlang distribution. So common pattern. You start state machine, you define different transitions, and you allow someone to transition state of your state machine, and also react on state transition and stop state machine, and live maintenance also. Common state machine pattern is here we have our client, here we have state machine API, and it uses a real instance of generic state machine. Client requests state transition, and state machine whether processes state transition or notifies another state machine, and this is very common used pattern within different online gaming, negotiations, different payment scenarios. So you have to negotiate states of your different parts of your system. So again, it has its callbacks, and they are slightly. There are two mods. So this one is callback mode. So we can choose between different modes, whether our state machine we will define functions or we will handle these as events. Init, terminate, code change. You already know it. So when we start our state machine, we add what? Yeah, it initializes specific module with and also executes callback mode. It checks callback mode. Then gen state machine, we can call and cast messages, and it will end up handling events, and we can stop it, terminates, and other different messages are defined just like handle events. And this is an example. Okay, yeah. So I'm gonna open. Okay. So this is a bit longer. Yeah. Let's navigate. So here is our API. Yeah. Here is our initialization. Here is our states management. Here is our states transition mapping. And this is, I don't know, random events handling. Okay, let's let's take a look step by step. So these are our allowed state transitions. So this is basically our API, and this is common pattern. You implement behavior, you just export some functions, export. So it's a common practice to export client API separately from callbacks API. Then you just call state machine to start it. Then it registers it locally, and it stops, etc., etc. It calls it, and this is it. So when you call state machine with its name, it's defined later in the very end. Yeah, name is some. Yeah, this is it. Okay, so you just pass the name of event, which is basically like the request to state transition. This is our boilerplate code, initialization, blah blah blah, termination, code change, and this is it. So if you plan to define event machines in Erlang, in Elixir as well, this is something that you have to deal with. So I spent decent amount of time to get used to this, but it's fairly simple. So we have our requested state transition and our current state. And if everything is okay, we define next step what we define. So we can set next, like here, we just leave the same state because we request nice weather and just request indeed, but we don't change state. But here we do change state, and this is new state, name of state, and this is also some data which is passed by state machine in internal loop, and it's also its state. So you have two facilities to store some data. Okay, so this is received message, blah blah blah, and this is our state transitions map. I'm intentionally not writing state transition diagram here. So when we are in offline state, and the only one state transition allowed is handshake. This is just a model of client connecting to server. So you just can take it and use it after forking on GitHub. So we offline, our client, which is basically raw TCP handler or HTTP handler, requests state transition handshake. Then it sets new state for this client state machine. Then from connecting, we can go to ready, which will end up online and or disconnect. And this is our sort of helper function. If you can see, our functions have guards. So you should be already aware if you are using Elixir, excuse me. So these are guards. So this function is not going to be executed if this guard doesn't doesn't evaluate to true. So we have some sort of helper function to check available transitions. Generic state using Elixir. This is it. Generic state machine. So nothing yet. But Erlang's generic statem works in Elixir. That's why I don't have Elixir version of state machine. Oh, supervisors. How much time do we have? 5 minutes, okay. Supervisors, I was worrying that I have not enough information. Okay, start supervisor. Yeah, this is the only. This is the only thing that we want to do is basically start supervisor. And common pattern: start supervisor, then start sub processes. What? Sorry, it's just animation. Okay, we'll come to. Yes, start another supervisor. So what we are able to do with this is just this. Who will just check video? It's once again. Okay, sorry. So we have our client, we have our supervision API, and we can manage children or start-stop supervisor. And when supervisor starts, depending on strategy, it starts its workers and monitors or links to them. And also it can start another supervisor, and via this pattern we get supervision trees, which are very important in Erlang applications. Applications. So what callbacks? Just init, and that's it. Okay. So different strategies, one for one. This is really really powerful. One for one. We have one supervisor, and during initialization, it starts all its available or all its workers. And if one worker goes down, supervisor just refreshes or responds yet another worker using the same identifier in its children map. So another strategy is rest for one. What it means is supervisor starts workers in an ordered manner. So it starts worker 1, 2, 3, 4. This is a good pace. And if worker 2 fails, supervisor just stops other workers and respawns the whole missing part of chain. This is useful if you have some pipes and filters architecture or some filtering. If one stage of your filtering fails, you don't need these, so these parts will be unusable. So it's necessary to restart rest for all. Yes, the next strategy is one for all. What it means is if one worker dies, supervisor just kills all other workers and restarts the whole chain, not only in ordered manner. And one last is simple one for one, very simple, definitely. So our client tells, so supervisor starts without any children. Our client uses supervision API to add child and add, or remove child. So by this way, you can dynamically define your children. Delete child, start link, yeah, start child, okay. This is our drone, and yeah, it's a worker. Every supervisor within OTP Framework works with generic behaviors. So our worker complies with generic or implements GenericServer. It starts, and yeah, it can get its name. So it's just boilerplate. And what is necessary is supervisor. Yes, this is official Elixir documentation. So I was trying to find an Elixir. So I think, by the way, GMO is one of ONUP clients. So so here how we define, yeah. So this is it. I don't know whether it's José Valim or GMO or ONUP. Okay, so this one part blows my mind. No, this particular part 3 times blew my mind. So we have yeah, we have workers module which is being used, its name in registry and its identifier within supervision tree. So we define strategy here, and our supervisor starts all 3 workers at once. Ooh, this is supervisor second with simple one for one. So we don't start any workers, we don't define them, but we can start them dynamically. And these are REST strategies. So you just call supervise. And what is vital is that this is the only one callback which you need to implement, and it must return whether okay, blah blah blah, children specification, supervision specification, or ignore, or something else. So if you are planning to work with them, you should definitely read the documentation. Application, functional application, which consists of processes, of running processes, and library applications. So these are just libraries full of code. Callbacks, just start application and drink beer. So application is in Elixir. I'm not using Erlang here intentionally because in Erlang it's a little bit trickier. But if we have such magical mixed project here, and here is our application definition. It's basically its name, its version, and it's some dependencies, some blah blah blah. So what we register, we use our, so we say that our drone app module is basically implements application callback, application behavior. So yes, so our drone application looks like this. We have one supervisor and we only start it. This is common pattern, and this is the supervisor. We already saw it. It's just one for one. We will drink beer and I'll show this how it works. Releases, yes, this is tricky. So just Google about releases because it's lots of tools, lots of information. But I ended up using only one yet. So it's XRM. It caused one exception, but if I have I have the patch, and there is a bug report in GitHub with rel-x library. So never mind. So what you need basically is just mix deps compile, get and compile, mix release, and go to your console, the console of your application. This is it. This is how you release your application. Then you can just target RPM, Debian, FTP, STP, etc. And if you read books, Erlang books, this is something very tricky. This is .up file which defines application. Well, it's bullshit if you have a mix. Another one, very important part within Erlang community also is a rel file which defines release. So how to do upgrade? It's a joke. So we have our deps compile, release. We have open console. I'll open it when we have some beer. We can update the code to meet up to next minor version. Then we just once again compile and release. And we don't close our console. We open this script, execute it again, giving it just version. And what it produces is a release upgrade script, which is basically a scenario how to upgrade from blah blah blah, and application upgrade, which is a set of Erlang terms, which is instruction for Erlang runtime system to upgrade your modules. If you change some state within your modules, it will be stated here, so it will end up using example application. Okay, so thank you for this. Yes, this journey. Please. Sorry for loading you with all this stuff. I think if you, okay, so Q&A.
How?
What?
How?
How much? What for? How?
What is the purpose of this application?
Yes. Which application?
What does it do?
Which? It's not an application. Sorry, I've described just OTP constructions. There is no simple application here. No, but yes, this example application will be here is the some sort of chat with TCP via Ruby client. So we'll just click consoles, but it's not here. I mean, it's here, but it's not here. Any more questions? Was it useful?
Yes.
Oh.
Make some like 3 sentences of your conclusions.
Yes. Yes. So my conclusion is, let me open the first slide, and not for no. One of It just determines. Yes, this is it. So this is why it's useful. It's true parallelism on your virtual machine, on your one instance. Moreover, we haven't covered distribution, how Erlang treats nodes. Just when you write application, you don't necessarily need to know that your application will be clusterized. You have global registers. Your nodes can be referenced and can be pinged, and you can send messages on processes on different nodes, etc., etc. So my conclusion is we should definitely learn Elixir if we have some heavy lifting applications in backend, because I haven't seen such concurrency level. And thanks to Elixir, a really low level of entry level. So if you are new to Erlang, if you are zero to Erlang, but you are familiar with Ruby, it's the matter of a couple of weeks to implement some serious application. And throughput is, or performance is really impressive. So we can Google it, just Google it. There are different benchmarks using plain Cowboy web server via plug and Elixir, and it processes like regular hello world. It processes something around 90,000 requests per second. Comparing to Ruby with rec, not Rails but Rack application, only 300 comparing to 90,000 requests per second. So it's really impressive performance and really for free. So if you need this, then you should definitely try digging it. Another option is a Go language, but as for me it's more C-like. I don't understand it. Okay, but Erlang, yeah, I have a block. C, no, thank you, not today. So Erlang really makes things powerful things very simply. Elixir, and I believe they will never have such fuck-ups like they have today with documentation, unfortunately. And yeah, this is this. Let me open.
Guys, do you have any questions?
Ta-da!
You have mentioned PID. Is it something system PID or something
No.
internal?
I have mentioned it. It's a process identifier within virtual machine. So
Okay, I saw.
yeah.
On system level.
So let's basically start our application and go drink.
And try again.
No, not try again, but
Respond your presentation.
it's the releases, the drawn up Elixir drawn application, and well, what is this? It's rel drawn up bin console. So this is our basically already released application. It starts supervisor, drone supervisor with two drones provided, IDKFA and IDDQD. You must have known this already. And what I'm going to do is observer start. What? What? Observer. It's Erlang. Yeah, observer. Start. What? Observer. It's Elixir. Yeah. So what happens? Observer start. Start. Yes, this is it. So we have our application, we have our supervision, very simple supervision tree, and we have our couple of our workers. We can kill them, and we can see that supervisor has just restarted our new worker. So what is a PID? Is this? It's something internal. So you should not rely on these PIDs, as I already said. That's it, guys.
Would you like to provide us several examples how we can use in practice infrastructure?
Yes, of course. You can see eJabberd. You can see Mongoose EM, which is a fork of eJabberd. You can see EMQTTD broker, which is a machine-to-machine broker. You can use RabbitMQ. You can use raw TCP sockets, which can handle several thousand TCP connections on only one node, which is one instance of Erlang abstract machine. So it depends on your productivity of your course. So if you need to have high connectivity, this is for you. If you need to have location transparency and clusterization, this is for you. If you need to be a competitor to WhatsApp, this is for you. Yeah. So it's up to you. Yeah.
Давайте вже персональні якісь питання підійдемо, бо люди вже
Okay. thank you. Thank you.